Good. So let's start now. Okay, later on, I will show this again. 88 Tuition would like you to do a Google review. We can do it later, okay? During break time and after the session. So look at the first question here. Your question 1 is actually question 22 in the actual mock paper. So we have a full mock paper, right? This is the question 22. Let me just look at your answers. Now, okay, don't be too stressed out today. All right, it's going to be more relaxing. Later on, we'll play a game of Kahoot. So not to worry. Okay, so question 1, which is the question 22. Oh, okay, only one person got it wrong. Now, I'll go through quickly for those questions that are like not big issues. So this is one of them. Okay, answer is actually D. Why is that so? You have 2 identical glass blocks. Okay, then Sammy pushed them with equal amount of force on the table. Block A traveled longer distance. So that means there is less friction here, right? There's less friction between the glass block and the table surface. Here, there is more friction. Therefore, it is more difficult for the glass block to glide on the table. So this must be the answer. Smooth surfaces usually leads to less friction between the things in contact. So we always talk about contact surfaces, less friction, it moves more smoothly. 23, okay, your question 2. Now this one also not a big issue. Yeah, let me just check. Yeah, only one person got it wrong. Let's see. What is this topic on? What do you think this topic is on for this particular question? Let's see your responses. Okay, which subtopic is it on actually? Galen actually typed in the topic. Pranati typed in something else. Good. Yeah. So Pranati even identified quite a number of things. Yeah, more and more of you are typing good. So it's matter and then the 3 states. So what is the state of this matter over here? Over the left-hand side at the start. What is the state? Very good. So solid, right? And then after that, it has turned into liquid. Okay, pretty obvious that melting has taken place, right? After an hour, imagine probably this is ice. Then after that, you get water. So what happened to this matter? It has changed its state. Okay, quite straightforward. Let's go on. Jensen left 3 similar glass slides. Do you know what are glass slides? Just like pieces of glass, thin glass. Have you used those for the microscope? Yes or not? Yeah, those are examples of glass slides. Have you all used that glass slide for microscope? Have you used the microscope before? You did, brilliant, good. Who else? Who else actually tried to put the substance on the glass slide and then place it at the microscope? Yeah, Sean did, good. Battle also did, good. In Science Center, the science lab should have many of this, right? I remember I used to open up the science lab during recess time. So students can go in, look at the microscope, look at the organisms, play with some of the science toys. Yeah, so every recess, we allow students to go in and play. I hope you all have that kind of chance also, If don't have, then give suggestion to the teacher. Okay, so you have glass slides here. They are actually originally placed in different rooms with different room temperature, right? So after that, they are being moved to room D. So this is room D now. In room D, something happened to one of the glass slide, and that is the third one. So it was originally in room C, right? There's water droplets form on this thing. So can you share with me a similar experience you had in daily life where you suddenly have maybe, let's say, maybe Battle or Shoria can share, okay, or even Sean, when you are inside the cab, you took a taxi to go somewhere else. When you get off the cab or got off the aircon bus, which is very cold, what happened? What happened? Especially those Wearing glasses. Yeah, the glasses will fog up, right? Yes, spectacles got this layer of mist. Pranati, you don't wear specs, you also know. Do you wear spectacles? No, but you know, you can see all your friends having that issue. Yep, Sharia said that is condensation. So what is actually the temperature of that spectacles? Is it high or low? Wait, the moment you got off the bus compared to the surrounding, it is very low, right? Very cold, very cool. Okay, yeah, you are using the correct words. So this must be from a very cold room where this glass slide has a cool surface. Okay, so cool surface. That's why water droplets form due to the process condensation. Okay, so the warm water vapor from the surrounding come into contact with the cool surface of glass slide 3, lose heat and condense to form water droplets, something like that, the full statement. If I change this to open-ended question, you're supposed to answer that way. So these two rooms, I will say that they are warm, all right, because there's no condensation taking place. So I can also say these two glass slides are actually warm compared to glass slide 3. And if we make this conclusion, of course, our answer will be C. Okay, so if you have gotten this wrong, I hope you understand now. All right, I hope you understand now. Yeah, some of you got this wrong. Okay, so room C cannot be warmer. It should be cooler. Okay, just imagine this is the aircon bus or this is the cab, the taxi. You were inside. You got off. Okay, and then this is actually the surrounding. So surrounding is warmer, the bus is very cold, so your spectacles became very cool and condensation take place. Okay, I'm going to erase this. Next question. Now, Zaki carried out experiment with 3 different objects, X, Y, and Z. Then he brought the ends of the object X and Y close together to test if they attract or repel. Now, 25, I think, let's see, 25. This question 4. So many error. Okay, let's go through this. Okay, now, after that, he brought the object Y and Z close together. So, what's the result? Okay, you see when the side here, A, is facing C, there's attraction. Attraction means nothing, right? Not a magnet and a magnetic material attracts anyway. So in order to check whether something is a magnet, we look for repulsion. Okay, we look for repulsion. Repulsion helps to confirm whether two objects are magnets. If they are both magnets, okay, you turn the ends, 2 ends will definitely repel. Clear? There will definitely be 2 ends where they face each other, they will repel. So only repulsion can help to confirm whether 2 objects are magnets. So if there's attraction, we don't have to bother. But the moment you see repulsion, okay, so A and D, if A is north, this must be north as well, right? So there's repulsion. Then you have B and C. B and C also repel. So if this is north, then this must be south, right? So let's now compare object Y and Z. So we are referring to Y and Z. You have C, okay, C, which is south, facing E, attract. So any kind of direction, it seems like there's only attraction, right? Now there's no repulsion. So what does it tell me? Okay, Z is not a magnet, right? But because there's repulsion here, I can say that X and Y are magnets, correct? Not? So A is correct. Now, it says also Y and Z are not magnets. That's not true. When separated, all 3 are magnets. That's not true because Z is not the magnet. Okay, this is a magnet. So answer is only A. Do you all see this now? Let me see your answers. Some of you put down C. Oh, B, C, D all have. B, C, D, we all have the students answering there or choosing them. Okay. Are you better and clearer of this question and answer now? Yes or no? Hopefully, yeah. Prita, can understand this part? Yeah. Yep, gotta let me know. Okay, next. 26. Study the diagram here. Okay, this is Michael Jordan. He aimed and he shot a basketball in the basketball hoop. So the dotted lines show the path of the basketball from the time it was released from his hand at point A to the time it stopped at point F. So which of the statements are true? Okay, so let's see. Not a big issue here. Only one person got it wrong. So I'm just going to quickly go through. Answer is actually C. Okay, ball has no kinetic energy at point F. Yeah, boys, the ball already stopped. So no kinetic energy is correct. The ball had no potential energy at A. This is not true. Okay, because it is at a height, right? So there is gravitational potential energy. The ball has the most gravitational potential energy at C. Yes, it is at the highest point. Most, because this is the highest point. Okay, ball has more potential energy at D than B. Not true. Okay, D is actually on the ground. So this is not true. All right, so let's go on. Question 27. Okay, do you understand this one? Do you understand how this thing works? Okay, I suspect those of you who got this wrong, you didn't really understand. So Benjamin inserted 4 identical nails. So these are the nails, 1, 2, 3, 4. Okay, onto a piece of the soft wood. He dropped 4 blocks, P, Q, R, and S. Okay, so all these blocks will drop onto the nail. Correct now, from the same height. The moment this thing drops, it's going to hit the nail into the board. Yes or no? Okay, it's going to hit the nail into the soft wood. Okay, so the length of the nail that did not go into the wood was measured. So after the block has dropped, then they start measuring this distance. Okay, they call it D. Now, if let's say this block is very heavy. So imagine only, I'm not looking at the data yet. So imagine this is very heavy. When it dropped down, do you think the nail will go in further or go in a little bit? If it's very heavy. Will the nail go in a lot further? Or do you think the nail go in a little bit further, right? Yeah. So what will the distance that you see be? What will the distance be when you see the D? Is it small or big? Shorter, smaller? Yes. So this is the idea. So if this is very heavy, the nail will actually be hit into the soft wood, right? So the distance will be very small. You understand now? Understand the relationship? Okay, so when I look at every of this data, he tells me that, okay, the distance left, okay, from the top of the nail to the soft wood is 1.5 cm. Seems like a lot. Okay, so do you think block P is heavy? It's not. Over here, in fact, because the distance here or the length here is the most, so this is the lightest. So followed by, okay, this must be the heaviest. Why? Because the length is very, very small, only 0.2. So Q is the heaviest, P is the lightest, R is the in-between, right? S also in-between. Okay, so this is heavy, this is light, and then P is lightest. Can you see this now? So do you understand why the answer is actually B? Okay, block P is lighter than R and S. In fact, block P is the lightest. Okay, S cannot be lighter than R. Okay, cannot be lighter than R. P is heaviest. No, P is the lightest already, so cannot be heavier. R is heavier. R is heavier than block P, okay? And block Q, no. Block Q is the heaviest. You understand now? So we can derive the answer this way. All right, so let's go on. One more.